Hi there. In today's video, we're going to set up a small little LiDAR unit, the TFmini-s LiDAR. It's about a $40 part that I bought. And if you remember in previous videos, we set up a HereFlow optical flow sensor, and it also has a little LiDAR. Well, that LiDAR isn't recommended for large distances, right? This LiDAR is a little bit better. It's not as cool as some of the other ones that you find on the internet that can go many meters, but this one will give me a measurement range of 0.1 to 12 meters indoors and 0.1 to 7 meters supposedly in outdoor scenarios, plus or minus 6 centimeters of accuracy. So what this LiDAR does is it uses light to detect objects in their proximity. Basically, you can see the two little sensors on it, the LED that'll be emitting laser light, and then the other one will receive, and it can detect how long it takes those light signals to bounce back to calculate distance to the objects that it's detecting. So ultimately, today we're going to just wire this thing up and get it sending telemetry data into Mission Planner, but we're going to end up mounting it facing down in future videos on the bottom of the drone so that we can tell how far into the air it is, up to about the 7-meter range. Should help with a little bit of stability and takeoff and landing, I'm hoping, and provide a second sensor that can be used in conjunction with the HereFlow LiDAR. So we'll walk through wiring, we'll walk through connections or configuration on the Cube Orange and through Mission Planner, and then we'll see the telemetry show up in Mission Planner and validate that it's all working. So come on over to the bench and we'll start hooking this thing up. Actually, before we show the physical connections on the workbench, I want to walk through a couple diagrams that I made just to kind of show you how the wiring is done for this unit. It was a little tricky, I guess. I had to figure out what wires connect to what on which serial port. This is a serial unit, so you must connect it to a UART on your flight controller. It's not DroneCAN. So what I did in this setup for my drone is I connected it to the serial 4 port. Now, remember in previous videos, I'm using the core carrier board and a Cube Orange Plus, right? So this is what my carrier board looks like. And this here is serial port 4 / I2C port 2. It's shared, all right? And so I created a cable. There's 6 pins in here. I created a cable where I only pulled off the plus 5 volt, the TX, the RX, and the ground wires. All right. So I listed the pins here, pins 1 through 6. Pin 1, starting from the left, is 5 volts. Pin 2 is the TX port on the core carrier board. Pin 3 is the RX port. That's the green wire here. Pin 4 and 5 are your I2C pins that we will not be using. So they are no connect. And then lastly, pin 6 is ground. All right. Over on the right-hand side here, where I have the TFmini LiDAR, if you flip it on its back, your LiDAR should look something like this. There are 4 pins on the back that connect to a JST-GH connector, a 4-pin JST-GH connector. And the leftmost pin here, the green wire, is TX. The white / black wire here, this dotted one, is RX. The red wire is plus 5 volts. The black wire is ground. Okay. And what you must do, you absolutely have to do this, otherwise it won't work, is you have to connect the TX wire from your TFmini LiDAR to the RX wire on the core. So the transmit from the LiDAR goes to the receive pin on the core carrier board. And this is what I tried to outline here with pins 2 and 3 on the core carrier board on the left-hand side. So TX on the core goes to RX on the LiDAR, which is the white wire here. RX on the core, the 3rd pin, goes to TX on the LiDAR, which is the green wire. Okay, so the 3rd pin here goes to the 1st pin over here. Very important you wire that up. And let me show you a little bit about what my cable looks like on this next slide here. So you can see I used some colors: blue, yellow, red, and black. Those are all I had available to me with these JSTGH connectors. And on this leftmost port is TX. Pin 2, the yellow wire, is RX. Pin 3 is 5 volts. Pin 4 is ground. Okay? And if you trace these colors all the way through, you can see where I have them connected on the JSTGH 6-pin connector. That's going to go into port 18 or J18, the serial 4 I2C 2 port on my core carrier board. Okay, so the red wire, the plus 5 volts, comes all the way, and on the core carrier board, it's the leftmost pin, number 1. The yellow wire coming from RX on the LiDAR goes to the TX pin on the core carrier board, which is pin number 2. The blue wire goes from the TX pin on the LiDAR to the RX pin on the core carrier board. Again, the next two, pins 4 and 5, are no connect, and then the 6 pin is ground. Okay, so use this diagram to build your own cable. I have a really short cable for this demo today. Ultimately, when we mount this on the drone, I'm going to have to build a much longer serial cable so that I can basically mount this unit towards the underbelly of the drone and then run the wire inside up to my core carrier board to make all the connections. So let's head on over to the bench now and look at how this actually looks when it's connected to the core carrier board. If you've been following along with the previous videos in my series, you would have seen that I've been building this electronics prototyping board for all the electronics that are going in my drone. Okay, so check out the previous videos if you want to know how I got to this state. Ultimately, in the middle here, I got a core carrier board and a Cube Orange Plus that basically all the sensors are getting connected into. Previous videos up here, Raspberry Pi and an Ethernet switch, BEC. I got a HereLink Air unit up here, the CAN ports down here, and ultimately the Hobby Wing motors down at the bottom that are off the view of the camera right now. Okay. So here we're going to connect our LiDAR to a serial port. Now if you remember, I just showed you the PowerPoint with how these wires are actually run. This is what the LiDAR looks like. I made this JSTGH 4-pin to 6-pin connector. Okay, so I just bought these pre-crimped wires and connectors on Amazon that let me make my own cables. So the back of your LiDAR looks like that, and there's the front, right? So we're going to take our 4-pin connector that we made, following the pin out of what I just showed you in the PowerPoint, and we're going to connect it into this LiDAR. Okay. Now the only other connection to make is connecting this to serial port 4 I2C2 on the core carrier board. That's the 6-pin connector all the way down here. Let me see if I got a little screwdriver that I'll use to point to it. So it's all the way down here. It's the second one from the right here. If you're kind of orienting yourself with the left is the front of the core carrier board, which is up here by the GPS. Okay, so this second port here is where we're going to plug our 6-pin JSTGH connector into. And that should go in pretty easily and just snap in. And that's it. Now remember, this wire is pretty short. It's just for kind of prototyping on this electronics board here. We'll make longer wires when I actually install it into the drone frame. But that's it. That's the wiring for this connection, the hardest for this component. The hardest part is making your cable. So what I want you to do now is you can go ahead and power this up, power up your flight controller, power up your telemetry connection. And we're going to go to the computer, the ground control station, and open Mission Planner and set the parameters to enable this LiDAR and then view its telemetry. All right, so let me power this up and then we'll move on over there. Now, just for reference, in my setup here, I'm using a HereLink Air unit or HereLink Air unit over here and a HereLink controller that gives me a Wi-Fi access point into this whole cube. If you're not using something similar, you may just need to plug your USB cable directly into your cube so that you can plug it into your computer. All right. Depending on how you're building your own drone, you may have differences. All right. So I'm going to connect wirelessly to this setup through my HereLink Wi-Fi access point that's booting up now, and I'll head on over to the computer and pull up Mission Planner. Okay, I'm back at my ground control station with Mission Planner connected to my flight controller. You can see I'm getting telemetry data. I'm in a basement, so I don't got a GPS fix or anything, but you can tell I'm getting a good battery reading over here, 25.14 volts. Before we go any further, I want to walk you through to my GitHub page, which will have the information you need to do the configuration of the parameters to your flight controller. So in the description of the YouTube video, it will take you to my GitHub homepage here for this project. It's called the Hexacopter build project. And if you scroll down a little bit, there's a link that says click here to access the wiki and documentation home folder. I want you to go there, and then you'll scroll down to the step-by-step build process section, and we're on video number 11, the TFMini-s LiDAR. So I want you to click into that page. From this page, you got a couple details about this LiDAR unit. If you scroll to the bottom, there's those pictures that I put in PowerPoint in case they're useful to you. And then a couple other references that are useful, right? The notes, I'll tell you the TX needs to be connected to the RX and vice versa. See pictures below for examples. I have a link to the actual ArduPilot page where actually this TFmini guide here, if I right click on the references, that will take you to the ArduPilot page itself. That gives a lot of details. This was a great help to me and shows you some connections with different board types and so forth. And then the last one you're going to need for the rest of this video is this ArduPilot configuration link here. That page is where I'm centralizing all the configuration changes I am making to my ArduPilot configuration, right? So the prior videos to this one, we have set up HereFlow, the HereLink, the Hobbywing motors, and all of that requires its own configuration. This page I kind of broke down into various sections. So this parameter settings area, and there's a section per component essentially. So here's one about the core carrier board. Here's one about enabling drone can. Keep scrolling down though. You're going to see one that are the parameters for the TFmini-s LiDAR. These are the connections that you're going to have to set to make this work. Okay, so I'm going to split my screen now. So we have Mission Planner on the left and our parameters on the right. And we're just going to walk through and make these changes. So in Mission Planner, go to your Config tab, and you should be on the full parameter list. And remember, I connected my LiDAR to serial port number 4 on my core carrier board. If you connected it to serial port 2 or 3, you're going to have to set this appropriately so that instead of setting serial 4 protocol and serial 4 baud, you're setting serial 2 or serial 3, whatever port you plugged into. On these parameters here, I'm going to filter down though to serial 4. So you can see I got serial 4 protocol is set to 9, and that is telling it that there is a rangefinder attached to this serial port. And then serial 4 baud is set to 115 so that I get a 115.2 baud rate. All right. The next step you're going to have to change is this rangefind2 underscore type. Now remember, I already have a rangefinder in my system at rangefinder 1. It's the HereFlow optical flow sensor and LiDAR. So I'm adding a second rangefinder to this drone. So I want to set mine to be rangefind2 type. If you didn't have that HereFlow and this was going to be the first rangefinder in your drone, then you would use rangefind1 parameters. Okay. In fact, if I show you rangefind1 in mine, my settings are already set up for the HereFlow. Right. So I'm going to change my filter to search for rangefind2, and you can see the type is 0, and I don't have these other parameters yet for the minimum centimeters and maximum that it can read and the ground clearance. The first thing I need to do is set rangefind2 type to 20 so that it knows that it's this been awake TFmini LiDAR. And I have to save and write those parameters before these other ones will show up. So I'm going to go ahead and press write parameters. It's going to tell me that it has to refresh all the parameters to show me the new ones. And so I'm going to let that happen. Okay. Now, the other 3 parameters you need to set are essentially for tuning this LiDAR. Rangefind2 min centimeters is set to 10, and that's telling the flight controller what the minimum distance is that the rangefinder can reliably read. So when it's less than 10, it's not going to treat it as a reliable reading. Additionally, the rangefind2 max centimeters, I'm going to set to 600, since it can't reliably read over about 600 centimeters in outdoor environments. If you're indoors only, you could probably make this number higher. And then lastly, this rangefind2 ground clearance is set to a 10. Okay, and you can read this parameter description, but it's the expected range measurement in centimeters that the rangefinder should return when the vehicle is on the ground, which is the minimum that it can read, right? 10 centimeters. So you set those and write it. And just to be safe, I press Control F and reboot my flight controller. So I bring up these menu options here with the Control F key, and then there's a reboot Pixhawk option here. I'm going to go ahead and press that. Now we should be able to go over to our data tab and view this rangefinder. So you have your tabs at the bottom in Mission Planner here. If you go to your status tab, you'll see the readings from all your different sensors that are connected. Scroll over here and we're going to scroll for the rangefinder objects here. So you can see I got rangefinder 2 is measuring 164 because it's just pointed at my ceiling right now. When I put my hand over it, you can see it's going down. It's reading much less. Now it's 2. I got my hand right over the LiDAR units. Okay, and as I bring my hand away from it, you can see it's changing. Right now it's set at, it's bouncing around a little bit, but 13, 14, 16. Rangefinder 1 is my HereFlow unit. It's right next to this optical sensor that we just hooked up. So if I separate them a little bit, you can see I can get different distances. Right now I got rangefinder 2, the LiDAR that we just hooked up, pointed straight down at my board. whereas rangefinder 1 is the here flow LiDAR and it's pointing up at the ceiling. Okay. So that's essentially how you can get a second rangefinder and set this up. If you wanted to, right down here, I click this tuning checkbox to get this graph component to show up. And then if you double click in here, we can uncheck the defaults, pitch, roll, my speed controller, current, and RPM. And if we go to rangefinder 2, you can check that and start to graph its value. Right? So right now it's reading a little over 168. If I start to wave my hand over it, you can see that graph changing over time. So kind of a cool way to visualize that data over time as well. All right, so that's this video with setting up the TFmini-s LiDAR. Hopefully you'll find this useful and be able to use it on your own drone. Thanks for watching.